and start recording. Okay, so regular expressions. Yeah, this is a small cartoon with some guy. Everybody stand back. I know regular expressions, and then pow, it's like a superhero move. So with regular expressions, they're like a mini language to extract patterns from texts, very powerful and useful to know. So that's why we included. So I'll first show a couple of slides and then a quick demo with Google Colab. So what is a regular expression or regex? So it's a small programming language, if you want, where you can look for patterns in text. For example, you know, maybe some of you know wildcards. So that's the star. So that means if you're searching for something like Antwerp, you can type star Antwerp star, and it will match all strings containing Antwerp and then some characters before or after that. So that's what a wildcard is. And for example, if you're looking for all text files in the command line, I'm not sure how many of you have used the command line before, but you can type star text, which means you match with all file names which end with .txt. So here's a more complex example. So for instance, suppose we have a web page and it contains email addresses of several students and teachers. So you have this HTML file, it contains a lot of details, but you're only interested in extracting email addresses. So here with email addresses, actually it's links to email addresses. I mean a string starting with mail2, then a first name, dot, last name, maybe there are two dots, at the @ sign, then uantwerpen.be, or for student email addresses, student.uantwerpen.be. So I want to extract all these strings, and then I create a regular expression for that. So here's the example. It starts with mail2. So that means I want to match all strings starting exactly with these characters. Then it has square brackets, and you have AZ, capital A until capital Z, O till 9, and then slash dot. So what that does mean is you want to match any string which has any of these letters. So either lowercase or uppercase characters, all digits, and also the point characters. And the plus means one or more. So that matches pretty much every name you might have before the @ sign. Then you match the @ sign. Then the string ends with uantwerpen.be. There's a slash before the dot because dot has a special meaning. That's why there's a slash before that. And then you have these parentheses with a question mark, and then student. That means you should have student followed by dots, but it's optional. So that's what the question marks means 0 or 1 occurrence of students. So with this string, this special string, we call that a regular expression, and you can match all email addresses. So that's useful for extracting some patterns from text. And so here's another example. We have a sentence, which is our input sentence. Jan Willems lives in Antwerp 2000, Frankrijk 100. And then you might want to find all substrings which contains either Antwerp with an uppercase or Antwerp with a lowercase. So the regex for that will be square brackets and then capital A or A. So the square brackets, it's actually an or relation, and you want either a capital A or a lowercase a followed exactly by Antwerp. So that's the first regex. You can also have you can also search for all lines with either Antwerp or Brussels, and then you write this straight line, and then it will match either Antwerp or Brussels. You can also have all lines with Antwerp and the Frankrijk, but there can be anything between those. So for Antwerp, again, we don't make the distinction of the A if it's in uppercase or lowercase. So we had this OR clause before that, and then you have dots, and dot matches any character. So here in my string, you have the 2000 and a comma between Antwerp and Frankrijk-Les, so we want to ignore that. So we say a dot, which matches with any character, a star, which means 0 or more times any character. And so with this regex, you match any line which contains Antwerp, followed by any characters, and then contains Frankrijk-Les. You can also match all numbers, so the postcode and the street number. So that means any sequence of characters, so the plus means one or more, and then you have OR, so either either any digits, so any sequence of digits you can match. Also specifically for a zip code always in Belgium at least contains 4 digits. So you can match that with this regular expression. So 4 times a digit between 0 and 9, or you can just say 4. That's the second variation. And you can also find all street names ending with straat or lei. And so you say straat or lei with a straight line between the quotes, and then it's preceded by any alphabetic characters, so in lower or uppercase, and then you can match Frankrijk, Les, or blah 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 street with that notation. So these are some examples. So what are the applications of regular expressions? You can do some validation of data. So if you want to check if a certain column is indeed an email address, you can check that with a regular expression, or the format of an IP address. So that means 4 integers separated by a point, to check dates if they are in a certain format. So for validation in your program. Also, you can extract data, like if you have addresses or something, and you want to extract postcodes or email addresses from documents, as we saw in the example before, all URLs in a web page. So extract some strings from unstructured text. You can also replace patterns with a given string, so kind of find and replace. Find files matching a certain pattern, or also for parsing, so information from maybe a web server log. You can use regexes for that. So here's a small overview of the language. So a single dot characters means that in this position you can have any character. So any random character can be a digit, a letter, special character, doesn't matter. That's what dot means. Then you have the rectangular brackets, so all the characters within these straight brackets, it's like an OR. So if one of the characters in the list occurs, it's fine. You can also negate that. So if you don't want any digits, you can put rectangular brackets and then this notation, and then you can match some characters if they're not in the list. Then you have the quantifiers. So star means a single character or group of characters can be repeated 0 or more times. A plus sign means a character can repeat it 1 or more times. And a question mark means it can occur 0 or once. And you can also have the curly brackets and specify that it must occur exactly 1, 2, 3 times, whatever. Then you have the straight line for an OR, so either you have pattern 1 or pattern 2 that match. This is the in yellow here, the first symbol denotes the beginning of a line. So if you want to match something at the beginning of the line, a dollar sign if you want to match your regex until the end of the line. And finally, you can group patterns. So yeah, it's like in mathematics where you group pattern like this. And then Some characters are special, like the dot can match any character. So if you want a regular dot exact matching, you have to escape it. So, and then some others special definitions is like /d matches only digits, so it's equivalent to the straight bracket with 0 until 9. S matches any white space, so a new line or a space, and W matches, with a slash before it, matches any alphanumerical characters, and also the underscore. And so with these symbols, techniques, you can create your own regular expression. And then I'll propose that I skip the slides and just focus on a Python notebook. And so these regexes, you can match strings with them in Python. And we use the RE library, regular expression library in Python. So you have to first execute import RE. And then you have 3 commands for matching strings. So match, search, and find all. So they all 3 get the pattern as the first argument and the string where you want to search in as the second argument. So match will check if the pattern, the regular expression pattern, checks whether it occurs at the beginning of the string. Search will check if it occurs at any position in the string. And find all will return all occurrences. So if you have a number in your string, you want to match that number with a pattern, and you have several occurrences, you can use find all, because search will only return the first occurrence. So that's for finding patterns. Then you can also do find and replace or splitting. So splitting, if you split with a regular expression, you can split a string into several pieces. For example, you can use the \s, which means any white space, to split a string, and then you will split on all spaces. Or you can also use sub, and then it will replace all occurrences of the pattern with a replacement in your string. So that's in Python. If you want to make regexes faster, you can always compile them. So you can first compile the pattern, and then you can run all the commands above on the compiled version. So here's an example how to do this. So that's useful if you're matching against millions of lines and you compile the pattern one time and then match it millions of times, then it's a little bit faster. So I'm now going to share my screen for Google Colab. Wait, share application, Chrome tab. Okay. Okay. Can you all see this? Okay. Okay, so here's my first example. Wait, I'll zoom in a little bit. So I have a piece of HTML here with email addresses. I have Dieter Brugmans, @student, U Antwerpen, and Lynn Veermans, and I want to extract it. So that was our first regular expression here. So I'll just do an import first, the first time only, and then I'll search for the pattern. And so I want to search for any string starting with mail2. Then I want a name, so Lynn Veermans or Dieter Brugmans. So that means all strings consisting of alphabetic characters. Let's say they can also be in uppercase. In the example data, they're also in lowercase. Can also contain a dot. And you have one or more of these characters. So you have one or more alphabetic characters or dots repeated. Then I have an @ and then I have either uantwerpen.be or studentuantwerpen.be. So they both have to end with uantwerpen.be. I'm going to escape the dot because this means any random character, but I actually want a dot in this case. And it can also have student at the beginning. So that's an optional group. And so this group is optional. This group means, this means one or more alphabetic characters repeated. So that's also kind of group. Now I'm going to run that. So data, on the data, and if I execute this, oh, I made a mistake somewhere because it doesn't return any matches. Wait, group. Oh, no, there's no. So let me check what I did wrong. AZ students uantwerpen.be. I don't see immediately what my mistake is, so I'm going to run it on a part of my expression. Allez. Is it? Wait, I think. Do something like this. None, mail 2. Strange. I'm doing something wrong, but I don't know what. Okay. I think I didn't load the first cell or something. Well, I'm gonna copy paste this. So, and I have my first match here. And that's normal because I use array search. So if I want to find all matches, I have to do array find all, and then I can have the results here. And so here, because I have different brackets here, it will return every group as a separate part. So each result will print this tuple in Python with all the 4 groups. So I have my email address here. So I think if I do something like join results, it will just print the email addresses. Voilà. So that's what I want. So that's the example with the email addresses. So here I have some simpler examples I shown before with the Jan Willems example inputs, and then I can search for Antwerp. So I can also do match. But match, sorry. So search will search the entire string, and match will also only search at the beginning, so it won't return any results. So I have to do search or find all if I want all occurrences. So this is just Antwerp, and of course I can also make it. The case doesn't matter. I can do it like write it like this. And then if you want to find all numbers, you have this. So you have the digits 0, 2 until 9 repeated 1 or many times. So if I do this, I extract 2000, then 100, and then 11, and I can extract all numbers. So it's very useful in these applications where you have semi-structured data in text and you want to extract it with regexes. You can do it quite in a quite verbose way. Can also find all zip codes. So in this example, I want to match with 2000, 2010, 20, 30, 40, but not anything above 50. So that means I want to match all strings starting with 20, and then I use the not notation. So this means not followed by the character 5 till 9, and then ending in 0. So it will match 2000 and so on, but not 2050, 60, and so on. So that's an example with the not notation. Then I can match both Frankrijk-lei and Italië-lei. So that's with this regex. Pretty obvious. So you have the one group here. So it has to end with lei, the string. Lei. but the first part can be Italië or Frankrijk. So, and then we have splits. So if you have the original data here, sorry, I have to first execute, it's data2, sorry. Data2, and then you want to split it, and I can do array splits, and I can split on all white space, so that's /s. It will return me this, oh, sorry, will return this. But here you have a problem with the punctuation. So you have here star, here also, sorry, the dots, the punctuation lives in Antwerp. Here you have the comma, so that's not what you want. So you also want to split on all the punctuation characters. So then you're gonna split, I'm gonna split on white space or on point or question mark, and I have to escape them because these are special. They have a special meaning, regular expression, or exclamation, or comma. So if I have encountered any of these characters, one or more of them, I want to split the data. And if I do this, I get a more clean split and all the punctuation is removed. Yeah? What you could also do is write it in two things. So I could also first remove all the punctuation using sub. So I could say I'll remove all dots and question marks and exclamations and commas and just replace them with a space. It's also something I could do. And I have to pass my original data string as well as an argument. Yes. So this removes all the punctuations from the string, and then I can just do splits, white space, so /s of my original, of my string here, s. And then you can also do it that way. And you also have a clean split. Here I'm gonna add plus because you can have, if you look at the string here, you can have one or more spaces after each other. So if I match on S plus, I don't get these empty things in my string. So that's also a nice way to convert a sentence to a set of words. And for example, if you're doing some text processing or natural language processing, then this could be a first step in extracting words from each sentence. So again, here to remove all alphanumerical characters. So here I'm going to match on all digits, all alphanumerical characters, but I'm going to negate that. So in effect, it's going to match all non-alphanumerical characters and replace them with a string. So that's also a way to do it. It's more general than this. For example, if you have other special characters, then you all will have to add them all, while if you just say not letter or digits, you replace all special characters, all non-alphanumerical characters in one go. Okay, so that concludes the examples using regular expression. Then I'm going to quickly show you two ways to get data from the internet using HTTP. So you all know what HTTP is now. And there are two things you can do. I'll start with the second example actually. For example, you can go to the VRT website, and normally you do that with your browser, but you can also do it from Python. So if I'm doing this, voilà. So this means, I'm going just, this means with, I have here my URL, yeah? And if I import request, so you have to import it, sorry, import requests. And you can go to this URL with get. So request get URL, and what you do is you send a HTTP message with the get command to get this website. And then you get the result back and you get the text out of it, and then you get all the HTML code. So this is the HTML code. So this is the encoding. If I just go, if you go to the normal website, you see this visually. Wait, let me just quickly share it. So, wait, 1 second. Share. Yeah, you can go to the VRT news site, and then you see this information visually, so with all the images, but you can also do it from Python. And if you look at the headlines today, for example, there's a new Mars rover apparently. I can check that here in the text, and you see nieuwe verkenners. Of course, there's all these HTML formatting around it, so that's for visually making the layout of all that, all those instructions for making it visually attractive. But I can now use a regex, and I can say I want to find all lines where it contains VRT teaser title texts. Search that data. So I can find these matches, and I'm going to loop over these matches for S in print S. Return. Okay, no, now you have the VRT title text exactly, but actually we want the group behind that. So I'm going to say point star. Okay, this looks more promising. And so now you can see, so this is today's news. Yeah, it's in Dutch. Straks landt nieuwe verkenner. En so on. Politicoloog Karel de Vos over voorstel nieuwe staatshervorming. And so that's a way to effectively extract information from the web. We can do more processing, and like here, the quotes, it's actually it's HTML encoding for just having a quote, and so you can do a replace this quote with this. That's more readable, and you can also have this character at the front, so we can also replace that, clean it up a little bit. Or if you want to replace all HTML formatting, you can also do that with sub. So we can substitute all HTML code. So that means something like this. With the regex, all tags. And then you have closing line for the end tag, which is optional. And you have any name of the tag, any characters repeated once or more, and then the closure of the tag. So if we do this, we get away with these span elements at the end. We replace it. So let's see what this returns. Voila. So, and now I have all the headlines extracted. Here with my regex is still something wrong. Yeah, wait. Yeah, no, it's okay. So now I removed all the tags. Yeah, okay, still have to replace. Just going to use a string replace function in Python. And I have all the headlines of the VRT news now in Python, and I don't know, use this and make a program out of it. They're duplicates, so you could add a set or something to remove duplicates, but that's just probably because it's stored twice in the data, maybe one as a title and then hidden or something. That's the problem when you're handling this raw data such as HTML. So that's one example. So you can just remember that with HTTP, with import requests, you can get any URL from the internet and then extract data, for instance, using regular expressions. And then another example is this website. So there's a list of publicly available web APIs. And the difference with web APIs is that they return JSON. So, for instance, if you go to this site, to the GitHub public APIs, you have a bunch of public APIs, some of which you know, like from Google, Google Maps, Google Search, they have public APIs. And the first API I got here is for extracting information about cats. So that's this URL. And then you import requests, and then you get using HTTP this data. And here you don't have, here this is a web server, so it returns JSON. So JSON, you can easily traverse the data. So if I execute this, I get a result in JSON, which is useful because JSON is a structured file format, so I can loop over every key. I can say for a key value in data items, prints the key and the value, something like this. Like the data items. Why does it not work? Print data. No, indeed, it's an array. It's an array, so I have to go for items in data, print item. So it's a structured data format, and then you see here I got 5 items in an array. And each item has a number of properties, like the message, text, and if I just print the text, you see that this web service returns quotes about cats. Not really useful, maybe, but it's just an example of using a web service with JSON and HTTP. So there are also other APIs. Often you have to pay for them, for example, to get the current price of some stock in financial applications, things like that. Or also in Google, you can find, I don't know, the route from Antwerp to Brussels using a JSON. Probably there's also a web API for that. Okay, so this concludes my small interactive presentation and my presentation on regular expression. So this afternoon in the lab session, we're going to practice regular expressions in Python using Google Colab, and also do some exercises on pandas together with Dieter Brugmans. Are there any more questions? Any questions? No? Okay, then this concludes this session. See you next week. Bye.